Okay, wow, I'm surprised this thing still works. Yeah, I haven't streamed in like so long. I thought my stream key would just like not work or it would have like expired or something by now, but apparently it hasn't. So, yeah, I guess I'm live. Cool. Oh, I should change my title though. Uh, yeah, we don't need a description. It's fine. Okay, cool. Just change the stream title because I'm slow and I forgot about that. It's been so long since I streamed that I kind of forgot how this all works. But yeah, I just wanted to stream today because I just kind of felt like it. And yeah, it's a new year. Hooray! Happy New Year, everyone! If you're watching. And yeah, I've had a pretty interesting 2021. Just wanted to talk a little bit about that because it's gonna tie a little bit into what I've been doing with the randomizer and what's kind of happened with that. So I don't remember the last time I streamed. Obviously, the last time I streamed, I was talking about logging or something, and I mean, a lot has happened recently to kind of. I don't know. I don't know if it's really changed my stance on that, but yeah, I kind of got busy with real life things. Um, was mostly focused on work for a while, so yeah, I didn't really have a chance to work on the randomizer much. Obviously, a lot of that was self-imposed. The Rust meetups have been going really well lately. We've uh, had some pretty um, big names, I guess, relatively speaking, from the Rust community come in and do talks, and that's been a lot of fun. So yeah, things have been going pretty well there, and yeah, the randomizer is not dead. I definitely still been working on it. There's a few things I want to talk about before I dive back into the randomizer updates, though. So yeah, one of those things is that recently I've actually gotten a bit of an injury in my right thumb, and it seems to be permanent. So it might be RSI, like a repeated stress injury, which kind of sucks. But yeah, I can't really use my right thumb as well anymore. But it's not the end of the world. Like I can still mouse pretty decently. I just can't really like grip things and lift them. So yeah, that's one thing that's kind of prevented me from doing a lot of a lot of the plans that I had. Like I had this big plan of things that I wanted to do over my winter break. Like I have a few weeks of vacation, but like two of them got pretty much entirely swallowed up because you know a lot of my friends wanted to go out, and it was nice getting together with a lot of my old friends like in real life and hanging out with them, just yeah, having fun, catching up, since a lot of them I haven't even spoke to since like the pandemic started. So yeah, that's something. I'm drinking jasmine tea, by the way, in case that comes through in the microphone that I'm drinking liquids. Yes, I am sipping tea. But yeah, I basically have like a week and a half, or I had a week and a half left. Now only basically half a week left of vacation, and yeah, been trying to rest my thumb, hoping that it would kind of recover, but it just hasn't really recovered at all, which kind of sucks. I don't really know how it happened either. Like, I'm guessing it is repeated stress from mousing or something like that, mousing, keyboarding. But I mean, it doesn't hurt when I'm mousing at all. Like I said, it only hurts when I'm like gripping something or like pressing something with my thumb. So I don't know. It kind of sucks, and I've been kind of learning how to use my left hand for more things instead of using my right hand because I'm naturally right-handed, but it's been an interesting learning experience what it's like to live life as like a left-handed person. Like a lot of stuff is not built for left-handed people, and you really feel that when you've got all this like right-handed equipment and suddenly you have to switch to being left-handed, and like trying to click a mouse with your left hand, um, unless you flip the buttons around, you have to like you have to use your middle finger to left click and stuff, and it's a little bit weird. And of course, my manual dexterity with my left hand is a lot worse, so like moving the cursor in general is a lot harder. But yeah, whenever I want to give my right hand a rest, I just kind of switch over to the left hand and let that try to do its thing for a while. But sometimes it's just too much of a hassle. So I'm currently just mousing with my right hand right now, and it doesn't hurt, so it's not really a big deal. But yeah, I'm just hoping that it's not really damaging my right thumb any more than it probably already has, or any more than I honestly don't know what happened, but yeah, I've given it like a week now and nothing's happened, nothing's changed. So, oh well. So the other thing I want to talk about is the thing that a lot of people really wanted to talk about at our last Rust meetup, even Log4Shell. That's pretty interesting, pretty serious security vulnerability, or I guess there's been like several of them now. I remember there were like two that were discovered right away, and then a third one got discovered a little bit more recently in that Log4j library. So yeah, I mean it's kind of like that dependency injection book was talking about. I don't know if I've ever talked about that book on stream or not, but I've been reading, or I was reading this book on dependency injection in C# at one point, and the author is like really big into functional programming, at least from what I've seen in some of his blog posts, and he's done a lot of kind of neat things, and he apparently wrote some book on dependency injection in C#, and so I decided to take a look at that because I generally have to work with more object-oriented languages for like actual work. And yeah, I mean I learned a few things there, and one of the things that they brought up was injecting stuff through the constructor, such as like loggers and stuff. And yeah, they even addressed like the fact that a lot of people think they're safe behind their logging facades, and sometimes that's not really the case. And we've now witnessed that with Log4j. That sometimes all the bugs are actually in the logging facade itself, and it's nice to be able to keep yourself separate from that and not have a hard dependency on it, so that you don't have to worry so much about issues happening upstream that affect literally every part of your code base. I mean, logging itself is a cross-cutting concern, so yeah, removing that hard dependency is kind of nice. And I know they also suggested the more what was it called, aspect-oriented design approach, and yeah, I thought that was kind of interesting. I don't know how feasible that is in Rust though, so yeah, it is making me kind of second guess my decision of just kind of going with tracing. And we did have a talk recently at our meetup about web development in Rust, and yeah, the topic of tracing did come up, and I think it was even suggested that if you really don't want to commit to using tracing, you can always use a logging facade, and apparently tracing does implement the logging facade. I didn't know that because it didn't sound like it did from what I read last time I looked at the tracing library. Let's go look at that tracing RS, because yeah, I didn't think that it worked with log, but maybe it does. I know there's like this tracing log thing, and I'm pretty sure there's like some kind of like binding for it. Yeah, I'm not sure. If I look up facade, well, they have this listed under logging facade, which is weird because it sounded to me more like tracing is not a facade, it's more like an implementation. Yeah. So I don't know. I still have to figure out exactly how I want to use this thing, I guess. But it was suggested that tracing be used for, your web apps. And it seems to me like most applications are, well, most places are kind of suggesting this as like the logging library to use because it has structured logging and support for async. Uh-oh. Whew. I just had to sneeze there. Did that pick up? I hope not. Well, I have no idea. Hopefully I muted in time and it didn't actually go through, but yeah. What else? What else? No, that's it. That's all I really had to say today. Um, yeah, that's the major updates. I guess I've become indecisive again about logging in general uh, because of the whole log4shell incident. But yeah, I don't think I'm going to be changing plans in the near future. I think I'm just going to use tracing and whatever logging facade is most popular in Rust. Um, I mean, the likelihood of something majorly bad happening is fairly low, I would say, especially because of the way that Rust does log macros. It's like everybody's logging library seems to use like the same logging macros, or at least syntactically. So switching libraries probably isn't that big of a deal, even if it ends up being another like log4shell situation. Well, actually, I guess I can't say that for sure. Like, who really knows? But I don't know. It's a risk. I guess I'm willing to take that risk, and yeah, we're just gonna move on, hope for the best. Uh, yeah. So the next thing I want to talk about is the actual randomizer and the updates there. And there's actually quite a lot of updates. So I wasn't just sitting around doing nothing this break. I actually have been working on the randomizer, even if I wasn't going through my gigantic list of other more research related things I wanted to do this break. So one thing you'll probably notice here is that everything's implemented now. It's not actually working yet. Like, I haven't actually been able to run it and compile it and all that. But it's built off of a prototype I made a little while back that definitely does run and work. The code was kind of messy because it was just a prototype. It wasn't particularly great. And I did kind of cannibalize my original Rando engine that I posted on GitHub a while back because I didn't really like the API there. I realized that I was kind of putting like a hard dependency on petgraph everywhere, and in the end I kind of decided that this graph trait that I have here in randomizer should actually be an abstraction over not just the petgraph library, but kind of a more of a high level abstraction that hides a lot of the underlying details of, I guess, how the graph works and how it operates. Like, when I'm swapping edges and stuff in the graph, there's a bunch of like index stuff happening. Like, I'm getting like they're almost like handles for the edges and the nodes of the graph. But yeah, you get like an edge index back every time you add a new edge or a new node. You get a node index and stuff, and I kind of have to like manage all of that. And the way that I've kind of designed the randomizers, that we have like these swappable edges, and then there's like the static ones that can't be swapped, right? So yeah, that's all kind of abstracted away. And so at the end of the day, we get this nice oh, I guess I haven't opened that yet. We get this nice simple algorithm, right? I have this like number of iterations here that I want to make configurable at some point, but yeah, this is like the whole thing. this is the entire shuffler. We just call the graph to pick some random edges from the swappable edges that are available, and then we ask it to swap those edges, and then we check is the graph still completable, like can we still beat the game with those edges swapped the way they are. If not, then we swap them back, and that's pretty much it. So yeah, it just kind of tries, and if it fails, then it just swaps things back, and that way it guarantees that the graph is always beatable. Yeah, I've got this like precondition here. I might move this. I might keep it and then like duplicate the check in like the actual loading of the graph data. But yeah, that's pretty much all there is to the shuffler. The graph implementation has all the really nitty gritty, nasty stuff, and the code here is significantly less clean. I'd say like a lot of the code I'm pretty proud of. There's some parts that are less good. Like this part is a bit slow because I ended up wanting to avoid a panic here, or a potential panic. Like what I really wanted was this signature to be this like vector of like vectors of node IDs. So I didn't really want to make that into a result. And it might make sense to make it a result, but I just feel like this is kind of one of those operations that really shouldn't be fallible at all. So yeah, I decided I wanted to just ensure that this thing wasn't fallible, and I went with this slightly slower solution. I don't think it'll impact things too much, but it might be a problem. If it is, then I can always switch to a solution that does panic. Or like, well, in theory it will never panic, and in practice I hope it never does if I go with that route. But there's like this very remote possibility of a panic, and so I was kind of scared off by that and decided, nope, I don't want to introduce that kind of risk into my code base, and went with this solution. Because there's a way to use like condensed graph.get node weight for a given index, right? Like a node index. But it returns an option, and the panic was coming from unwrapping that option. Like there's no way that it should ever not be able to find the node weight for a given node index. But if for some weird reason in the future I decide to like insert some logic in here that might screw with that, I don't know why, but you never know, that would kind of cause everything to break down. So yeah, that's what was going on there. But most of the rest of this code fairly clean. I mean, these errors, yeah, I think this is probably about the best I can do here. I need to actually return proper errors. What else? There's a bunch of stuff missing still, but yeah, there's like a ton of logic here. There's a bunch of stuff I want to actually remove too. Like I have these string IDs, but I kind of realized at the end of the day that my JSON data that I'm loading probably shouldn't be using strings for IDs everywhere, because that kind of sucks. And I don't really want to do that. Like I have this weird mapping where I map the string IDs to like integers to try and like avoid passing around strings everywhere, but then the integers have to be mapped to like node indexes, or node indices, sorry. But yeah, it's kind of a mess. There's too many layers there. If I just like I have to have the node IDs, like that's a hard requirement, but I don't have to have string IDs. Like they could just be numeric. It's just that the JSON becomes a lot harder to read. So I don't know, if I had some kind of like editor, like a graphical editor that generates the JSON, that would be a lot better. Because I don't have that though, it doesn't really work out that nicely, which kind of sucks. But yeah, I'm thinking what I could do is move the strings from being IDs to just descriptions, and that way I can at least keep like a map of like the node IDs to their descriptions, and then from there, if I need to get like debug information about like which nodes were problematic for whatever reason, like maybe we try to swap two edges and then the graph isn't beatable, and we want to return some kind of error saying like, hey, this is why the graph isn't beatable, like these nodes aren't reachable, kind of thing. I can at least print something like human readable out, which would be pretty nice. Like yeah, having like written string descriptions is very helpful in this case. But yeah, that's basically all that's happened here. I'm currently just working through like the error handling. So there's a bunch of results that need to be returned, and I haven't actually returned errors in any of those cases. Like a lot of them are panics, or a lot of them are returning errors of the wrong type. Um, what else? So there's one more place in the code that I haven't really fixed, or like I haven't properly implemented, and that's the rocket state. I think that's what I was talking about last time I streamed, which was quite a while ago, but essentially I need to be able to load the configuration, or like basically load the ROM data once, right? Because I somehow have to get that that JSON data into the randomizer here. But I don't want to do that every time like a request is sent, because that's stupid and wasteful. It's just incredibly slow. So I decided what I would do is, yeah, just do it once on startup and pass the relevant information after we load it down to this state, and that state would be held somewhere and we could access it whenever we need to, but we're not going to ever update that state. Just makes things a little bit easier, and there's no need to update that state at all. So yeah, I need to look into how to make that stuff happen. But aside from that, yeah, I can't really think of much else. I might do a little bit of work right now on the error handling while I'm kind of just dabbling around with this code. So I've finished, I think, updating the ROM writer module, so all the errors here are correct as far as I can tell. And I am using this error. Oh, actually, I need to box this. I just realized. Yeah, that needs to be boxed. Yeah, there we go. Okay, now this should be done. I'm going to compile everything a little bit later, because I know there's going to be tons of errors still. I want to get everything... I want to clean up as much as I feasibly think I can, and then I'll try to compile it. And then I'll work through those compiler errors, because at that point there should be relatively few. I don't know, that's generally my workflow for a lot of these kinds of projects. Maybe not the best way of doing it. Maybe I should have just been gradually compiling things as I was changing them, but it's... I don't know. When I'm kind of just trying to write down my logic and get it done, I don't want to be stopping along the way to like think about, oh, how should the errors be handled at like every point, right? I usually want to just go code the happy path and then let the compiler kind of just tell me like where are all the sad paths that you didn't properly handle. So I like to do a second pass over everything to just go back and handle all those cases. And that way we don't like lose track of what I'm doing and accidentally, you know, write the wrong business logic. I don't know. It's definitely more of a me thing than anything else, but yeah, that's generally how I like to do things. Like, thankfully the compiler does have my back. Although I did add a lot of panics everywhere. So these panics were in the prototype, and I did copy a lot of that code into here. Obviously, this is what I have here is a lot cleaner, and I made sure to like have a purpose for every abstraction that I added, like trait wise, and yeah, that's actually one thing that I learned is pretty important, is that whenever you're making an abstraction, you have to really you really gotta like justify it, right? You have to really outline like what is this abstraction for, and why do I need it, or why do I want it, right? Like what is this actually doing for me? And you know because there were a couple of choices where it was a little bit ambiguous. Like when I was writing the graph trait, I didn't realize at first that I was going to go to such a high level of abstraction. I kind of thought it was just going to be a very thin layer over top of the pet graph library. But as I was working the code, I realized that I kind of wanted the algorithm logic to be as simple as possible so that it was readable and understandable, and because that's the part where that really needs to be correct. And I wanted to kind of hide more of the implementation details of the graph. So yeah, I kind of learned that I really need to be more specific about what I want from my abstractions, especially that graph abstraction. Like what I have right now, I think is pretty nice, but definitely something I should have outlined to begin with a lot earlier in the process before kind of running into that wall and going, uh-oh. I just realized that I'm trying to, change things at two different levels of abstraction. Uh-oh. So yeah, that was an interesting experience, and ultimately what I ended up with is, I think, a lot simpler. It's a little bit slower in some cases, but you make trade-offs. That's all software development is making decisions. There's never really any silver bullets, well, at least not most of the time, and you're just constantly trying to make trade-offs and hope you make the right trade-offs. But yeah, I'm gonna try and remove some of these panics. Well, in the places where I feel like I need to, at least, and add some new errors using this error. I mean, this is definitely giving me more practice with this error. Since I want to get rid of this code, like the string IDs entirely, I feel like these panics, I'm gonna leave them for now. Yes, I know they can take down the entire server. I don't care. I'm gonna be getting rid of this soon-ish. So yeah, that's what I'm gonna be working on today. Oh, and I also want to, I guess, address the agile elephant in the room because I kind of dropped the whole agile methodology entirely after a bit. Like, I'm not really following the sprints and stuff because life got in the way. So yeah, I guess this whole board thing. Oh, actually, I actually closed my last board. I never created a new one. I never created a new sprint. I think that was a smart decision. I kind of realized that Kanban boards, they are great, and it's good to track status and progress and stuff like that. And it's kind of nice to see that, steady, like, sort of empirical way of measuring progress. But at the end of the day, I find that really mostly works if you're kind of like on a set schedule. You're not completely derailed by other things happening in your life, and if you want to really follow that like agile Scrum methodology, like it really works a lot better with that. I wasn't really having as much fun writing code in that way. Like, I was getting more stuff done, I feel, and it kind of worked for a bit, but I really couldn't hold myself to those kinds of deadlines. And yeah, I find writing code a lot more fun when I'm able to just kind of take it at my own pace, not worry like too much about getting stuff done on time, and worrying about like the end results. Like, if I'm just slowly focused on the code itself, trying to make it look nice, trying to make it readable, making all those hard decisions on like where the abstractions should be and all that, then I really feel like I'm in my element. I'm having a lot more fun writing code that way, and like I kind of realized that that the really like super duper agile way of doing things wasn't really working for me, at least on this like solo project. Like, for a work project, sure, right, you've got deadlines, sometimes you have to make sacrifices, because you got to deliver stuff on time, and code doesn't always end up being perfect or exactly the way you want it, and that's okay. I mean, you're also working with other people too, so you also have to account for that. But when you're working on a project on your own like this, and you're not really like bogged down by those kinds of things, to me it just feels a lot better to not to just like not try and like rush things out. And yeah, ultimately I feel like it's done a lot of good things for this code base. Like this little bit of code here, um, hell of a lot cleaner than the original implementation. Same with this. Like this is also much cleaner, um, a lot more readable. The abstraction boundaries make a lot more sense. I had like some overly long names in a lot of places because trying to name stuff when you have functions that have way too many responsibilities really sucks. Or when you write a really badly abstracted out function, like the original abstraction for swap edges was super weird. Like there was a helper function that did like most of this, and you had to like inject like the functionality you wanted in each of these like case branches as like lambdas and stuff like that. That worked, but it was really ugly. And at the end of the day, I ended up going with this much simpler, much cleaner design. I mean, yes, this thing's kind of bleeding off the side of the page, but hey, believe me when I say the old implementation was a hell of a lot worse. And I've also kind of learned to embrace the imperativeness of this code. Petgraph itself is very imperative, I would say. Like it kind of expects you to do these like kind of inserts and stuff and get like the indices out, and you're kind of mutating the graph step by step. Yeah, and inherently it just feels very imperative to work with, and trying to force a very declarative style of programming onto the code wasn't really helping. You'll see a little bit of that in my code base still in some places where there's like a bunch of like flat maps and chains and stuff like that. But yeah, in most cases I found that it was just easier and more readable to just check the if condition and do like an early return with an error. And it feels like that's more idiomatic too. I've seen that in a lot of other Rust libraries and stuff. So yeah, I've kind of learned to embrace this sort of thing. Am I getting spam bots in chat? I feel like I am. Yeah, I feel like I am. Cool. Maybe I'll moderate that in a bit. I don't know. But yeah, like this code here is fine, being as like declarative as it is. I think that's totally cool. But other places, not so much. And this could also be less declarative as well if I wanted to go with the faster solution, and that would also be pretty clean. It'd be like 2 or 3 lines instead. But this is also a lot safer, or not like a lot safer, but it helps me sleep at night basically. Let me put it that way. So yeah, that's pretty much it for what I have to say about like the updates here. Yeah, I've kind of fiddled around, just kind of scrolling through the code enough, I'd say. So let's actually try, implementing some stuff. So I guess the first thing I want to do is move this down a line, because that was pretty ugly the way that it was. I don't think Rust cares about white space, so this should be fine. Like, I think you only need the braces around your cases, bars, when you have multiple lines, like multiple statements in a single, or well, yeah, if you have like, if you have to use a semicolon, and then another statement after that, or another expression. I think that's when you really need to use the braces, but otherwise this is actually okay. Rust format probably would have done this as well. Yeah, speaking of which, I actually don't have Rust format or Rust analyzer enabled right now because I didn't run nix develop, and that's, I don't know why I didn't do that. But I have the syntax highlighting, and that's good enough for now, and I will run the nix develop script a little bit later once I feel like it. Once I'm done, once I feel like I'm at a reasonable place with the code, and then I can actually start fixing Rust analyzer issues. But The way that I have errors right now is I have like one gigantic error enum, I believe. Oh, this is the wrong module, of course. It's not very gigantic right now, but yeah, I wanted to add this like edge swap error type, and I do think I need to add this. I don't know if I want transparent though. Let's see. Oh yeah, and for the unbeatable graph stuff, I definitely need to... Whoa! Oh, I definitely pressed the wrong key there. Visual block. What did I do? How did I get this? Was that Control Q? Oh, okay, interesting. Wait, how... Okay, I'm distracted now, but I kind of want to see how this works. So if I paste that here... Oh, okay, that's actually pretty cool. Alright, I dig that. Yeah, I might actually use that. I didn't realize that Control Q did that. I think I was reaching for Control W because I wanted to go up to the other window. Yeah. So, yeah, this result is my own custom result type, the one that's defined down below with the Katam Rando error in the error case. I guess I should talk a little bit about my error handling strategy, because error handling is a bit of a thing in Rust. Especially because it's so different compared to other languages, unless you're used to Haskell, of course. But yeah, my error handling strategy is just have everything in a giant enum, and I know that that's not necessarily great, because if you've seen that blog post on like problems with typed errors, let me look it up. Something Matt Noonan typed errors. Wait, is it not Matt Noonan? Never mind. I think it was someone else. Someone wrote about like problems with typed errors. The trouble with typed errors. Matt Parsons, not Matt Noonan. Yeah, if you've ever seen this blog post, like this blog post has a lot of great information about why typed errors aren't really the perfect error handling solution. It kind of outlines a lot of the problems. Like, let me think. So, because I have this one gigantic enum with all the error types that can happen in my application, I could potentially, return nonsense errors in functions that really shouldn't be able to return errors of that kind. Like, if swap edges returns a Katam Rando error, it could return like a ROM write error or an unbeatable error, even though the only error it should be able to return is an edge swap error. So it's like, oh no, that's more error prone. You also have problems with like wildcarding, right? If you have a wildcard case for handling errors, then whenever a new error is added to the enum, that gets automatically handled by the wildcard. So it's like you're not actually explicitly trying to handle that case, and that could lead to problems later where you actually did want to do something special for that case, but you didn't, and the code silently compiles and says everything's a-okay because you wildcarded. And so that's another discussion. I know a lot of Haskell code bases that actually like to ban wildcard pattern matching. It's definitely an interesting topic, and I've seen a lot of stances on both sides for why you should or why you shouldn't do that. And yeah, I've kind of just said I'm probably not going to use wildcard pattern matching for error handling, and yeah, I'm okay with having this giant error enum because there aren't really a lot of other great solutions. It's one of the major trade-offs of using typed errors, and I mean, it's not exactly like exceptions are better in any way. They're a lot less composable, for one thing. Like, you can't be generic over exception types exactly, like the way that you can in Rust with its results. And yeah, generally results is just more flexible in that regard. And exceptions have other benefits. Like, checked exceptions can allow you to list out each of the individual errors in your type signature, whereas in Rust with your enums, you're not really saying explicitly what kind of errors you can return. You have to kind of look it up. You can't just like take a set of errors, like Katam Rando error, and then add one new one just for like one function. Like you can't like union it with another error. That doesn't really work. With anonymous sum types, you can do stuff like that, but Rust doesn't have them. So yeah, we kind of have to live with what we've got, and you know, it's not so bad. I mean, Haskell's worked like this for God knows how many years now. So yeah, there's no perfect solutions. I need to look up this error because I just realized I actually don't know what I'm doing. Let's see. Okay. That's one way of doing things. I could just store the store a string, and then it'll interpolate that there. Sounds good. Okay, I'm gonna assume that this is a bot now. Add moderator, mod the bots. I think I'm just gonna remove this for now. Yeah. I mean, it's not a harmful message, but still, I don't like spam. No spamming in the chat if you're just a bot. Yeah, I think I'm gonna go with something like this. I think that'd be fine. Edge swapping isn't particularly... Well, what kind of information do we need when we want to swap edges? Or like when we fail to swap edges? Like, what? So why are we failing to swap edges? We're failing because we got a mismatch of edges. So we got like a one-way, and we're trying to swap that with like a two-way edge. So I think actually I don't think there's any other information that I need to care about here. All I care about is the fact that this actually like I don't even really care what edges they were, as long as, you know, a one-way got swapped with a two-way. That's based on the input that comes in, right? Like that's like an API usage error. So yeah, I'll just say like incompatible edges. Attempted to swap incompatible edges. That's probably good enough. Yeah. Just double checking that this looks the way that I think it does. Oh, they don't actually use sentences. They use like sentence fragments. Okay. Sure. You can do that. And this should be a Katam Rando error. All right. Very good. Yeah, I think that's all I really want to put here. We're already early returning here with this question mark, so that's fine if we end up in this error case. Okay, so these errors now. I guess there are different kinds of edge swap errors, technically. Like, there's failing to get the edge from the swappable edges, and then there's, you know, trying to swap incompatible edges. But this is more like a user error, right? Like someone's misusing the API, they get this error, that makes sense. This one is more... This is more like... The program invariant was broken. Like, this is a case where you'd probably want to panic, but I don't want to panic because I don't want the server to just, like, die. So... Yeah, I kind of have to think about what I want to do with this. It definitely needs to be a different kind of error. We'll call this one like an incompatible edge swap, and we'll add another case for... missing swappable edge. Yeah. Now, the edge that I'm going to get... I think it needs to implement display. Because, yeah, it's going to be a swap edge. Swap edge is defined up here. It's copy, clone, hash, partial, equality, debug. Okay, so it has debug, but I think it might need display. Or I could do something like this. Okay, that's interesting. Okay, so 0 for tuple struct. Got it. That makes sense. Alright. I understand. I just need to add a string here? Or... No, I need to add a swap edge here. Yeah. We'll add a swap edge there. We'll just do... we'll use the debug implementation for that. Because that has the edge index. Like, there's not a lot of good feedback we can get from this. But it's also a case that shouldn't really happen. So, yeah. Alright, we'll return that there. I think I'll probably go for another few minutes here, and then I'll switch over to the next thing that I wanted to stream today after a short break. So, yeah, let's... Okay, I can't remember where I was. I should have done that ages ago. Why didn't I do that earlier? That was kind of stupid. It was swap edges, right? Yeah. Alright, so we're here in swap edges. Oh, I already added like a string here for that. Oh, look at my slow Vim navigation skills. Yay. Yeah, I still HJKL sometimes. Oh wait, this is a reference? Huh. Okay, but actually I feel like it doesn't have to be a reference at all, because like at this point you can take ownership of it. Like it's gonna get... Wait, is it? Okay, so we take ownership of the edges here. I don't know if that makes sense. Okay, and we already consumed those edges at this point. Ah. Yeah, I also haven't done any like borrow checking, so yeah, that might be a problem. Wait, did I? Oh yeah, this was incompatible edge swap. I guess I should do something like this because I don't want to consume those yet. And I can't remember if you do this or if I have to use the ref keyword. I think if I use ref, it like dereferences it too. I can't remember. It might be ref. It doesn't matter. I'll find out when I try to compile it. That's kind of the point. That's why we use Rust. I will say, like, I've done a lot of C++ programming lately for work, and like some of the arguments that people get into about basic things in C++, like string concatenation and stuff, and like what is UB and what isn't, is kind of crazy. It feels like it's so complicated. And ownership rules, like nobody really seems to understand them, and so people just kind of just throw smart pointers around everywhere. Definitely very different from what I'm used to in Rust, where things feel a little bit more, I guess, sane. So I don't know. For me, it feels like Rust is a lot easier to learn than C++, but that could also just be my bias coming through. But at least in my experience so far, I haven't found C++ to be particularly friendly to learn. And like accidentally stumbling into like memory leaks and UB is a lot easier than I expected, I guess. I mean, I guess if you're used to that sort of thing already, it's not that bad. But yeah, if you're a beginner, it's very punishing. It's very, very punishing, especially when you get those nasty seg faults and you don't know what's going on. Like we were trying to debug this one seg fault that was like related to like their to like a build system, and like, oh my god, like it wasn't even like my fault. Like I didn't even cause it, but yeah, it was a mess. I don't want to get into that too much right now. Anyway, I'm getting really distracted here. We're gonna go with missing swappable edge. So that's fine. I think here we can actually take ownership of the edge, finally, and do this. We have to return that, so that'll be fine. We can do that here as well. Oh, actually edge 2. And there we go. That should be enough to let the edge 1 or edge 2 live long enough to be consumed later. Actually, no, swap edge is copy clone. What am I thinking? I'm pretty sure I defined swap edge as copy clone, didn't I? What was it? Was it enum swap edge? Copy clone. I'm dumb. Why do I do this to myself? Yeah, it just hit me like a truck. Like, wait a minute. The reason why that's fine and why I didn't change that earlier is because it's copy clone anyway. There we go. Cool. Is that all for this function? I think it is. Yeah, this is now perfectly safe, I believe. So that's good. Is there any... Okay, so who calls swap edges? I'm pretty sure that gets called somewhere in the algorithm code. Oops. Swap edges, yes. And we question mark it, so we're fine. Okay, cool. That's taken care of. Is pick random edges fallible? Maybe it should be. Pick random edges. Actually returns option. Yeah, okay, so this is already handled. This is actually... Interesting. Okay. So yeah, it can fail, but if it does fail, we just kind of say, oh well, it's just we didn't get any edge, so or we didn't yeah, we weren't able to pick any edges, so we'll just return a none, and we already handled that case by saying, oh well, if I get a none, then I'll just kind of ignore it. Oh yeah, this is the first time I've ever used the matches macro. I actually found a good use case for it today, or not today. Whenever I wrote this code, which was like sometime within the last couple days. And this is a relatively like newly stabilized macro. Like I don't remember which version of Rust specifically, but yeah, this got added to the standard, or at least it was stabilized recently in standard. So that's really cool. I'm very happy to be able to give this thing a shot. Yeah, that's looking good. Like if that's not a problem, and I don't think it is. Yeah, these chooses all return options, so that's fine. We don't really care. I think that covers two of the methods here. Okay, so these print lines are terrible, and I need to get rid of them and replace them with tracing statements later, but they're gonna have to wait. I guess, is get edges okay? This one does return result. Right, so get edges is one of those functions that I wanted to change at some point because it returns string IDs, because ideally it would just return node IDs instead. Like we don't have to bother with the string IDs anymore after a certain point. So where does it fail though? Self-dot extract IDs. Oh, right, those panic. Okay. Interesting. Yeah, maybe this one actually doesn't need to return result then. Because eventually I'm going to get rid of extract string IDs, right? And then we're not going to need that anymore. So I want to say that this will probably be fine. Although, what does extract string IDs do? Well, it still has to get the node IDs. Yeah. So maybe actually this should return result, because that could be a problem. I mean, that'll still be a problem no matter what. I think that's fair. I mean, we're probably going to rename this function to just like extract node IDs or something like that eventually, instead of just deleting the code entirely. So let's do that. Was it randomizer? Whatever. Doesn't matter. And yes, I do realize I could be splitting this error enum into smaller enums. I did kind of do that for the ROM writer errors. Like there's a bunch of errors there, like error structs for different kinds of errors that can occur there. But in the end, I just kind of like box all that stuff up and make it into a trade object, because we also have to handle things like IO exceptions and whatnot. Or I shouldn't say exceptions, but you know, IO errors when we fail to open the file or like fail to write to the buffer. So I kind of just decided, you know, I'll just kind of lump everything together, and it's probably okay. So I want to actually return an actual error here, and get node IDs for edge. Get node IDs for edge returns what now? It returns a result. Oh yeah, so I'm using this by map. I'm doing this get by right. I don't know what that returns actually. It might actually be an option. Let me look up Rust by map. Yeah, I don't know how popular this library is, but I've been using this in place of just, trying to maintain two different maps. And overall, I think that this is probably okay. I probably don't need this bimap library, actually. It could cut out this dependency. There's also that linked hash set dependency that I have that I might be able to cut out with a B-tree map instead, but I haven't. I don't know. It's more code if I do that, which is a little bit more accidental complexity, I would say, versus just using the linked hash, the linked hash set, right? Like trying to convert the B-tree map into a hash set means like fixing one side, you have to like fix one side as like unit, and then you have to also kind of rework the API a little bit, I think, to make it more set like. Otherwise, it's just kind of weird. So yeah, that was one of the reasons why I stuck with the linked hash set. I was actually kind of disappointed when I found out that regular hash set in standard is non-deterministic in terms of like iteration order. So like whenever I try to like randomly pick edges from it, it's like actually completely random. But if I want to seed the RNG, like I can't actually have that. So despite the fact that this is a randomizer and I want things to be random, I actually don't want things to be random in that one case. So I have to use the linked hash set. It kind of sucks. What was I looking for? Get by right, I think. Yeah, getting distracted. Okay, no, I can see it right there. It returns an option. It's probably an option of some kind of generic type, right? Yeah, and it's a reference. So that's fun. What can I do about that? Let me think hard about that. So actually this is a reference? Does that mean I have to actually like dereference this? I feel like that's actually true. I probably have to dereference this. I just didn't realize that. We'll find out once we compile. But I think that actually, yeah, like no, like I read the type. It returns a reference. I'm pretty darn sure I need to actually dereference that, or maybe it will automatically dereference. Kind of doubtful, actually. The way that the Rust does coercions, still not something I've completely internalized yet. So you gotta bear with me here. Not exactly a Rust pro. I'm very proud with my progress I've made this year, but definitely still not what I would call like an amazing Rust programmer. Like I'd say I'm like fairly decent at this point, and I can hold my own writing Rust for like actual projects. But yeah, trying to like write the fastest stuff in the world, and yeah, knowing every little detail of the language is not something that I know, and maybe never will, because the language isn't exactly the smallest and simplest thing in the world. But this is actually an option, so I think I need to like okay or let me look up how that works. Rust okay or. There's an okay or and there's an okay or else, right? And or else is like the lazy version, which is like it only computes the else case if it actually needs to run it. Yeah, these are eagerly evaluated. It's recommended to use okay or else. Wait, no. If you are passing the result of a function call, it is recommended to use okay or else. Okay. Am I passing the result of a function call? I think so. Right? We're calling get by right. That's a function call. I don't know. That's a weird way of wording that, I feel. So it's gonna turn it into an okay if it's a sum, but if it's a none, then we get some kind of error. Oh, but we actually have to we have to supply the error. Right. Yes. Okay, that makes sense. So if I want to do okay or else, then I do a Katam Rando error. It would be the new one, whatever that is. Missing node or edge endpoint. Failed to get node ID. For edge endpoint. Well, actually, it's more like missing node ID. Missing edge endpoint. No, okay, I don't know. That's getting a little verbose. Maybe I shouldn't do that. Naming things is always one of the hardest parts of programming. It's well-known problem. Katam Rando error. We're gonna go with what? Missing node ID. And we get a node ID. Right, or not a node ID, we get a node index. But like the node index is kind of transparent. But if it's just like straight up missing from the map, then like what else do we really have to work with? I guess we have the edge index. Fail to get node ID for edge endpoint of edge with maybe. And then we just that's actually kind of a problem. I just realized, because now Katam Rando error is now it's dependent on pet graph, but Katam Rando error is not an error of crud. Okay, let me think about that. Let me think about that. I'm gonna take a break, I think. We'll come back to this. Maybe I'll finish this on my own time. I'll need to figure out a better solution for this. And yeah, I'll be right back, and we will be looking at something completely different after this short break. So I'm trying to figure out like what's a good solution for this. How do I? Because most people do like a BRB kind of thing. I guess I could go like a notepad, right? And then we could just make it like really huge. Like, whoa, it's massive, and be like BRB. Okay. BRB taking a short break. Okay, I'm back. Gonna quickly just check that OBS is still working. Yeah, that's fine. Is the stream still running? Yeah, we're still going. Alright, cool. So, yeah, we're gonna move on to our next segment here. But before we do, I wanna just start with a little story. So, I have a close friend who's, he's always kind of viewed life in a particular way. Like, he's always kind of viewed everything as a bit of a grind. Like, I'm not even joking when I say, like, there was a time in his life where he applied for like 100 jobs and he didn't land a single one, and so he ended up grinding LEET code problems to find a job, and eventually he did. And now he's gotten into like dating and stuff, and he's just kind of viewed it the same way. You just gotta send out like your application to like 200 different girls, and eventually like you'll find the one kind of thing. So to him, everything's kind of been this kind of grind, or as he likes to call it, like a numbers game, right? You gotta play the numbers game. And so he's kind of been encouraging me to kind of do things his way and view things as like a numbers game, and I should play the game, play the numbers game. And so what, I've decided that today I'm finally going to play the numbers game. We're gonna play the natural number game. So, yeah, no. I don't know, I just really wanted to do that lead up because it just kind of felt a little bit fitting. But, yeah, I've said before that I really wanted to do more, like, content related to, I guess, theorem proving and stuff, and, a lot of that came from the fact that I read the Idris book on type-driven development. I've also read Software Foundations by Benjamin Pierce. So I've done a bit of like theorem proving there. I've also I've read Cock for the Impatient or whatever. I can't remember what it's called. I think no, it's called Cock in a Hurry. And yeah, so I've also learned a little bit of Cock as well, and I've generally gotten more into proof assistance lately, as a result of learning more about dependent types and just seeing how cool they are and how expressive your code can really get when you have the power of dependent types. So yeah, I've really been enjoying programming with dependent types with like Idris, and looking at what kindlang is doing with its like optimal evaluators and self types and stuff like that, and Agda, Cock, all the dependently typed languages, and even looking into things like higher inductive types and like homotopy type theory. Although I will say I don't understand that stuff very well right now, and I don't know if I ever will, because I don't know. At some point, I feel like I should like read about topology and get a better understanding of that. But yeah, anyway, I'm kind of going on a bit of a tangent here. I've been hearing a lot about this little language called Lean, and I think Lean is like a language that comes from like Microsoft research. It's another proof assistant, and supposedly it's really fast. It has somewhat of a focus on programming as well. What little syntax I have seen of it seems pretty readable, and yeah, supposedly they're using this one technique. What's it called? Counting mutable beans. Yeah, so supposedly they've been using the approach from this paper to make their language really fast, and I've heard that there are actual like robots being built in Lean that have to like balance themselves in real time, right? Sort of like those like Boston Dynamics robots, and I thought that was actually really cool. Like, there's actually a fast proof assistant out there that can be used for like real programming, or at least supposedly there is. I don't know. This is just a rumor that I heard, so I don't actually know if that's true or not, but I figured, hey, I'm into learning these dependently typed languages. Why not learn a bit about Lean? And from what I know, it also has like a tactics language as well, which is pretty cool. Like I've kind of come to appreciate the tactics-based approach for theorem proving that like Coq provides, because it's a lot more like readable. It's very easy to like step through um, those more like the tactics syntax. It's a lot clearer like what the state is at each step, because you can kind of like step through it. Whereas with when you're writing your proofs as just like implementations of functions, like that works, but it's a lot harder to tell like where the individual steps of the proof are happening, and trying to like probe into that is also way more difficult. Like you have to delete some of the code. Oh my god, what is with the bots today? Go away. You have to like delete some of the code, and then you'd have to insert like a hole, and then you'd have to like inspect the hole to see like what is the goal there and what are like the hypotheses and the context, that sort of thing. So like viewing like the state, or like or like of any particular like sub goal, I guess, of a proof is kind of difficult when you're just writing proofs as implementations of functions. I don't think I've ever shown that off on my channel at all, and maybe I should at some point. But yeah, there's a very like different way of doing things with tactics, and tactics I find a lot more readable. I don't know, maybe my opinions will change on that, but I do know that Lean has like some kind of tactics language that I believe probably gets translated into regular functions under the hood. Like it's probably just all syntactic sugar, but yeah, I'm kind of interested in learning about Lean, and so the natural number game is a tutorial on Lean. I believe it also is sort of a tutorial on proofs as well. It says it's a part book, part game. It shows the power of induction. So naturally, we're going to be doing a lot of proofs by induction. That makes sense. I mean, when you're working with natural numbers, they're usually infined by induction. And yeah, we'll try to get as far as we can. I'll probably play for like an hour, and then I'll probably end stream. But let's get started. So yes, welcome to the natural number game, a part book, part game, which shows the power of induction. Blue nodes on the blue graph are ones that you are ready to enter. Gray nodes you should stay away from. A gray node turns blue when all nodes above it are complete. Okay, good to know. Green nodes are completed. Okay, I don't have anything completed. Actually, you can try any level at any time, but you might not know enough to complete it if it's gray. Fair enough. In this game, you get own version of the natural numbers called MyNat. There's a typo here. You might be missing a word. In an interactive theorem prover called Lean. Yay! Your version of the natural numbers satisfies something called the principle of mathematical induction, and a couple of other things too. Peano's axioms. Unfortunately, nobody has proved any theorems about these natural numbers yet. Oh no. For example, addition will be defined for you, but nobody has proved that x plus y equals y plus x yet. Oh my god. This is my job. Wow. You're going to prove mathematical theorems using the Lean theorem prover. In other words, you're going to solve levels in a computer game. Alright. You're going to prove these theorems using tactics. Yep. The introductory tutorial world will take you through some of these tactics. Okay, so it's structured in like a world format. Okay, so it's almost like Mario, right? The introductory tutorial world will take you through some of these tactics during your proofs. Your goal, what you're supposed to be proving, will be displayed with a turnstile symbol in front of it. If the top right hand box reports theorem proved, you have closed all the goals in the level and can move on to the next level in the world you're in. When you finish the world, hit main menu to get back here. Okay, cool. So yeah, we're gonna go as far as we can, and yeah, let's start gaming. All right, so Lean is busy. Okay, so I did do a little bit of testing beforehand to see how this is supposed to work, and it seems like sometimes stuff doesn't load properly. Like there's supposed to be a console down here, and there's supposed to be like a text editor up here, and It seems like neither of those loaded this time, so I might have to try and reset this. The game will reset. Hold up. Never mind. Let's just refresh. Yeah, this might take a few tries for it to actually properly load. Let's just read the preamble first and hope that it loads properly this time. Okay, so there's a few imports up here. That's interesting. Okay, well, half of it loaded this time. Great. So they've got import mynat.definition. So I guess that's their own definition of natural numbers. They're importing their addition and multiplication definitions. All right, let's get into level 1, the raffle tactic. Let's learn some tactics. Let's start with the raffle tactic. Raffle stands for reflexivity, which is a fancy way of saying that it will prove any goal of the form A equals A. It doesn't matter how complicated A is. All that matters is that the left-hand side is exactly equal to the right-hand side. Computer scientists would say definitionally equal. I really mean press the same button on your computer in the same order equal. For example, x times y plus z equals x times y plus z can be proved by raffle, but x plus y equals y plus x cannot. Alright. I find the NLab definition of definitional equality and like was it judgmental equality a lot more understandable, but like they don't try to like dumb it down in this way. I don't know. It feels more precise, so yeah. But it seems like this is aimed towards like super beginners, like people who've never done like any kind of theorem proving before. Anyway, let me keep going here. Each level in this game involves proving a theorem or a lemma. A lemma is just a baby theorem, okay? The goal of the theorem will be a mathematical statement with a turnstile just before it. Okay, I think they said that already. We'll use tactics to manipulate and ultimately close, i.e. prove these goals. Let's see raffle in action. At the bottom of the text in this box, there's a lemma, which says that if x, y, and z are natural numbers, then x, y plus z equals x, y plus z. Okay. Locate this lemma. If you can't see the lemma and these instructions at the same time, make this box wider by dragging the sides. So it's at the bottom of this box. All right. So down here. I'll get to it later. Let's apply the proof. Click on the word sorry, then delete it. When the system finishes being busy, you'll be able to see your goal, the objective of this level, in the box on the top right. If your system never finishes being busy, then your computer is not running the JavaScript lean, which powers everything behind the scenes, okay? Okay, so I'm guessing lean has a JavaScript backend, so the lean... Well, I don't know what they mean by the JavaScript lean. It could be like... Yeah, because they have to actually, like, compile and run the lean somehow. That's in here. So no, it wouldn't be like there's a JavaScript backend. Try Chrome. Try not using private browsing. Well, I'm not using Chrome, but I'm definitely already not using private browsing, so... I did get this thing to load at least once before. Let me try again after I read this. So remember that the goal is the thing with the weird turnstile thing just before it. The goal in this case is x times y plus z equals x times y plus z, where x, y, and z are some of your very own natural numbers. That's a pretty easy goal to prove. You can just prove it with the raffle tactic. Where it used to say, sorry, write raffle. Yeah, I mean, it literally just said that. And don't forget the comma. Then hit enter to go on to the next line. If all is well, lean should tell you proof complete in the top right box, and there should be no errors in the bottom right box. You just did the first level of the tutorial. Well, no, I didn't, but I guess this thing isn't that interactive. And you also learned how to avoid by far the most common mistake that beginner users make. Every line must end with a comma. If things go weird and you don't understand why the top right box is empty, check for missing commas. Also check you've spelt Reffle correctly. It's Reffle for reflexivity, okay? They're really trying to hammer that home. For each level, the idea is to get lean into this state, with the top right box saying proof complete and the bottom right box empty, with no errors in it. If you want to be reminded about the Reffle tactic, you can click on the Tactics drop-down menu on the left. Okay, resize the window if it's too small. Now click on the next level on the top right, blah blah blah, go on to the next level. And then we'll learn about the RW tactic. Alright, for all natural numbers x, y, and z, we have xy plus z equals xy plus z. Alright. Okay, there we go. If I click that, apparently it does actually load. So that's interesting. We're just going to type Reffle. And then the comma. Because it said that we have to do that. Okay, so the text editor is actually down here. I guess this just shows like the current goals and the hypotheses. And that updates in real time. That's actually pretty cool. So yeah, there's level 1 complete. Cool. And it says there's 4 levels in this world, so classic Super Mario Bros. 1 style, I guess. At least for this world. I don't know how many levels are in the next world. Alright, so that all loaded immediately. That's good. The rewrite tactic, or RW tactic. The rewrite tactic is the way to substitute in the value of a variable. In general, if you have a hypothesis of the form a equals b and your goal mentions the left-hand side a somewhere, then the rewrite tactic will replace the a in your goal with a b. Below is a theorem which cannot be proved using Reffle. You need a rewrite first. Delete the sorry and take a look at the top right box at what we have. The variables x and y are natural numbers, and we have a proof h that y equals x plus 7. Okay, so yeah, that's okay. So yeah, these are our 2 natural numbers. Here's our proof h. So okay, I see what we're going to do. Our goal is to prove that 2y equals 2 times x plus 7. This goal is obvious. We just substitute y equals x plus 7 and then we're done. In Lean, we can do the substitution using the rewrite tactic. So start your proof with rewrite h and then hit enter. But don't forget the comma. Did you see what happened to the goal? The goal doesn't close, but it changes from this to that. We can just close this goal with Reffle. Yep, I know. Alright, let me just do that real quick. So, RWH, and then Reffle, and then we should be done. No goals, proof complete. Yay, we did it. Alright, don't forget the comma, hit enter, enjoy seeing the proof complete. Yep. The other reason you'll know you're done is that the bottom right window is empty. When you finish reading the comments below the proof, click next level. Alright. Exploring your proof, click on Reffle, and then use the arrow keys to move your cursor around the proof. Go up and down and note that the goal changes. That's so. Oh yeah, it does. Interesting. So it's even more interactive than I thought. And it shows you the type of the current variable you're hovering over. That's interesting. So yeah, basically what it's doing is it's replacing y with x plus 7. Or it replaces whatever's on the left-hand side of the equality proof with the stuff that's on the right-hand side of the equality proof. It's good to know, because the direction actually matters. Unfortunately, that is a thing with proof languages. Go up and down and note that the goal changes. Yeah, you can inspect lean state at each line of the proof. Yep, I love it. Try to figure out the exact place where the goal changes. Where the goal changes is as soon as I press down. Yeah, as soon as I go from this line to this line. Yep, the comma tells Lean, I finished writing this tactic now. Please process it. Lean ignores new lines, but pays great attention to commas. Alright, good to know. Tactic index. The documentation for our rewrite just appeared in the list of tactics in the box on the left. Oh, okay. I wasn't paying attention. Play around with the menus on the left and see what is there currently. More information will appear as you progress. Bewildered? No, I'm not bewildered. No, there's no bugs here. Moving on. We just restarted Lean behind the scenes, so let's re-import the natural numbers, but this time without addition and multiplication. Alright. Oh no, are they going to make us write them ourselves? Alright, so we're going to learn about Peano's axioms. The import above gives us the type minat of natural numbers, but it also gives us some other things, which we'll take a look at now. A term 0 of type minat, interpreted as the number 0. A function suck of type minat to minat, so it's a function that takes a minat and returns a minat with suck n, interpreted as the number after n. So yeah, the typical successor constructor, or I imagine that they've defined this as like an inductive data type, but we'll see. The principle of mathematical induction. These axioms are essentially the axioms isolated by Peano, which uniquely characterize the natural numbers. We also need recursion, but we can ignore it for now. The first axiom says that 0 is a natural number. The second says that there is a suck function, which eats a number and spits out the number after it. So suck 0 equals 1, suck 1 equals 2, and so on. Yeah. Peano's last axiom is the principle of mathematical induction. This is a deeper fact. It says that if we have infinitely many true or false statements, P0, P1, P2, and so on, and if P0 is true, then if for every natural number d we know that PD implies P suck d, then Pn must be true for every natural number n. It's like saying that if you have a long line of dominoes and if you knock the first one down, and if you know that if a domino falls down, then the one after it will fall down too, then you can deduce that all dominoes will fall down. Yeah, that's the typical line of dominoes analogy that people use when explaining induction. Like that, I'm pretty sure that I was taught induction this way in like first year university in this exact same way as well. Well, maybe not exactly the same, but you know, they did use the dominoes analogy, I'm pretty sure. One can think of it as saying that every natural number can be built by starting at 0 and then applying suck a finite number of times. Don't you just love how it's called suck and it's like spelled like that? I mean, the concept of like the successor function has existed for like ever, but yeah, you know, because of how the internet is. Yeah, the meaning is, you know. Anyway, Peano's insights were firstly that these axioms completely characterize the natural numbers, and secondly that these axioms alone can be used to build a whole bunch of other structure on the natural numbers, for example addition, multiplication, and so on. This game is all about seeing how far these axioms of Peano can take us. Let's practice our use of the RW tactic in the following example. Our hypothesis H is a proof that suck A equals B. And we want to prove that suck A equals suck B. In words, we're going to prove that if B is the number after A, then suck B is the number after suck A. Now, here's a tricky question. If our goal is turnstile suck A equals suck B, then our hypothesis is H of type suck A equals B. Then what will the goal change to when we type rewrite H? This should be pretty easy. So we know that it replaces the left side with the right side when we do a rewrite. So suck A will be replaced with just B. So we'll have suck B equals suck B. And hit enter whilst not forgetting about the comma. I like how they always you know, reminding you about the comma. Don't forget the commas. Like, they're the semicolons of Lean's tactics language, I guess. Remember that rewrite H will look for the left-hand side of the goal, or the left-hand side of H in the goal and replace it with the right-hand side. Yep. Alright. Well, I already tried to figure it out in my head. I'm pretty sure I know how that's going to work. And here's the answer. Well, we are still in tutorial world, so let's just get this out of the way. Wow, isn't that amazing? Now we can just raffle that away, and then we're good. Level 3 complete. Where were we? The answer, Lean changed suck A into B, so the goal became suck B equals suck B. The goal is of the form x equals x. So you can prove this with REFL. Yep. Important note, the tactic RW expects a proof afterwards, yes. But REFL is just REFL. Note also that the system sometimes drops brackets when they're not necessary, and suck B just means suck B in parentheses. Ooh, this guide says brackets. So I had this TA in second year who's like a really, really big stickler for like calling these like round brackets parentheses. Like I think during one of our labs there was a student who accidentally called parentheses brackets, and like this poor like student like literally didn't know English as like their first language, and so the TA like had a hissy fit, and he was just like, no, those are not brackets, those are parentheses, get it right. And then he went up to the whiteboard and he was just like drew on the whiteboard like all three types of I guess brackets and he was like outlining like, these round ones are parentheses, these square ones are brackets, and these curly ones are called braces. So yeah, that's my brackets story. It's yeah, it was kind of weird. Not my favorite TA, as you can probably imagine. You may be wondering whether we could have just substituted in the definition of B and proved the goal that way. What do they mean by that? To do that, we would want to replace the right-hand side of H with the left-hand side. Oh, I see. Yeah, you can do that in Lean by writing RW left arrow H. Okay. And you can type the left arrow by using \L. Got it. So this is like, I think it's called SYM, like SYM in Idris. It's in Idris, I think it's like this. It's literally just a function where it just takes your rewrite proof and it just like swaps the order around. Sim probably meaning symmetric. So you can just edit your proof and try it. All right, sure, why not? Yeah, and this would also succeed if we tried to raffle that. Doesn't make a difference. You may also be wondering why we keep writing suck B instead of B+1. This is because we haven't defined addition yet. On the next level, the final level, we'll introduce addition. Okay, and then we're ready to enter addition world. Ooh. Alright. Last level of the tutorial world. So we've got addition. We have a new import, the definition of addition. Peano defined addition, A plus B, by induction on B, or more precisely, by recursion on B. He first explained how to add 0 to a number. This is the base case. So we've got add 0, which takes a minat and returns a proof of type A plus 0 equals A. Maybe I shouldn't read it that way. That's probably very confusing, but I mean, that's literally what that is. We will call this theorem add 0. More precisely, add 0 is the name of the proof of the theorem. Note the name of this proof. Mathematicians sometimes call it lemma 2.1 or hypothesis P6 or something. But computer scientists call it add 0 because it tells you what the answer to x add 0 is. It is. It's a much better name than Lemma 2.1. Oh, I don't know, man. Maybe maybe some people would beg to differ. You know. Even better, we can use the rewrite tactic with add 0. If you ever see x plus 0 in your goal, rewrite add 0 should simplify it to x. This is because add 0 is a proof that x plus 0 equals x. More precisely, add 0x is a proof that x plus 0 equals x, but Lean can figure out the x from the context. Now here's the inductive step. If you know how to add d to a, then Piano tells you how to add suck d to a. It looks like this. So we've got add suck, and takes two mynats. So it seems to use a similar syntax to Coq. I think Coq also defines parameter lists this way, like they're not separated by commas. Your variables are separated by a space. And you kind of have to like parenthesize, like if you have multiple different types and you want to take like if I wanted to take two mynats and I want to take a boolean, like I'd have to define a second list of parameters for the boolean. So here's a definition, I think. Yes. Okay, that's... Okay, so no, this doesn't mean of type. Or does it? Because usually the colon means has type. No, actually, no, I think this... Okay, so yeah, no, this is not an implementation. So this is actually also still just a... This is still a type annotation. So a plus suck d equals suck a plus d. Alright. What's going on here is that we assume a plus d is already defined, and we define a plus suck d to be the number after it. Note the name of this proof too. Add suck. Tells you how to add a successor to something. If you ever see ellipses plus suck ellipses in your goal, you should be able to use rewrite add suck to make progress. Okay, so this basically just like takes the suck inside of here and moves it outside. Yeah. But if you had like suck ... plus ... then you'd need to use like associativity to like swap the order of the two things before you could apply add suck. Alright. Here's a simple example where we shall see both. Let's prove that x add the number after 0 is the number after x. Alright. Delete sorry. Don't forget you can wind this box so you can, if you can't see the sorry. Observe that the goal mentions ... plus suck ... Yes, I know. I know how to do this. Don't worry. Actually, I didn't even look at the original goal. I feel kind of bad about that. Okay, so the original goal was a plus successor of 0 equals the successor of a. So that's basically a plus 1 equals a plus 1. And so if we apply this rewrite rule, suck wait. Yeah, suck 0 I guess becomes then we get successor of a plus 0, right? After we apply this rule. Yeah, okay. That's right. Let's see now. Okay, I did delete the sorry. I didn't hit enter, but the goal still changed. Tactic failed. There are unsolved goals. Okay, I'm guessing that's because we're not done the proof. I haven't really been paying much attention to this, but I'm guessing it's been doing that all along for all the previous proofs as well, and I was just going too fast to notice that. Yes, don't forget the comma. So now we can use rewrite add 0, of course, and that should get rid of the 0. Right? There we go. Now we can raffle. We did it! We're done the tutorial world! Yes! Now we can move on to the... Oh wait, we can't go to the next level though. There we go. Now it gives me the check mark. Awesome. So let's see, does this update properly? Yes, it is. Now it's green. Okay, so after we finish addition world, we get a choice. We can go to multiplication world or we can go to function world. Ooh, function world's actually has a much longer chain. So like, if you were trying to do like the any percent speed run, would you like finish addition world, go straight to multiplication world, and then skip all of these, and then go straight here, and then finish this? Would like, does that count as like an any percent speed run of this game? Or would you just like not do any of this stuff and just click on this and then just complete the last proof? Like, yeah, that's kind of interesting. I wonder how the how speed runs of this game would work. Like, I can already tell how 100% speed runs would work. You'd like complete every level in every world, and that would be like really easy to like define. But like any percent, like, I don't know. Right? It's not like there's like a credits roll. I mean, there's the thanks here on the first page, but then, you know, then you haven't really like played the game at all. Anyway, that's enough messing around. Let's get into the addition world. So, welcome to addition world. If you've done all 4 levels in the tutorial world and know about rewrite and raffle, you're in the right place. They also gave us induction. Okay, interesting. Here's a reminder of things you're now equipped with, which we'll need in this world. Data, a type called minat. A term, 0, of type minat, interpreted as the number 0. A function, suck, which takes a minat and returns a minat, with suck n interpreted as the number after n. Usual numerical notation, 0, 1, 2, etc. Although 2 onwards will be of no use to us until much later. Winky face. Addition with the notion or notation a plus b. Alright, so they're giving us addition. Yes, they tell us what our imports are at the top. Good to know. Theorems, add 0. So that's the one from last time. They're giving us that one, so I guess we don't have to implement it ourselves, although I don't think it's that hard to. And they're giving us add suck. Yep. Telling us how to use them even, although I'm already used to that. The principle of mathematical induction, use with induction. So I get the impression, the distinct impression, that this tutorial, this lean tutorial, is only going to be covering theorem proving and tactics, and we're not actually going to be doing any actual programming with lean. So like that's fine. I mean, it's good to understand both sides of the language, but yeah, it seems like this is pretty limited in scope, just based on what I've seen so far, and I guess I could have inferred that from the name of the game as well, but, you know. So they're going to teach us about induction. They gave us the raffle tactic, rewrite, and now we have induction. Induction N with DHD. We're going to learn this right now. Alright. Important thing. This is a really good time to check you understand about the box on the left with the drop-down menus. Okay, Navi, you don't have to tell me every 5 seconds. Check the box on the left. Hey, listen. Yep, all the theorems are there. You can find all you need to know collected there. Yes. Click around, yes. Yep, it'll grow. I understand. We only need one more tactic to really start going places. Alright. That's fair. Level 1. The induction tactic. Okay, so this world has 6 levels. I don't know if I'm actually going to finish this world today. We'll see. Let's see induction in action. We're going to prove 0 add. It takes n of type minat. Alright. And we're going to... Okay, so this is... Okay, this is what we're actually going to try to prove. Okay. 0 plus n equals n. Fair enough. That is for all natural numbers n, 0 plus n equals n. Wait, what is going on here? Didn't we already prove that adding 0 to n gave us n? No, we didn't. We proved that n plus 0 equals n, and that proof was called add 0. But now we're trying to establish 0 add. I think like these tactics are like not, like, they're not tactics, but these proofs are named very differently depending on which language you're using. Like I think they have usually like an L or an R to indicate like which side in Idris. But this is an interesting way of doing things. Like calling one add 0 and calling the other one 0 add. But aren't these two theorems the same? No, they're not. It is true that x plus y equals x, but we haven't proved it yet. And in fact, we need both add 0 and 0 add in order to prove this. In fact, x plus y equals x is the boss level of Addition World. Oh, okay, so there are bosses in this game. And induction is the only other tactic you'll need to beat it. Ooh. How fascinating. Now, add 0 is one of Peano's axioms, so we don't need to prove it. We already have it. Yeah, indeed, if you open the addition world theorem statements on the left, you can even see it. To prove 0 plus n equals n, we need to use induction on n. While we're here, note that 0 add is about 0 add something, and add 0 is about something add 0. Yes, I figured that out. The names of the proofs tell you what the theorems are. Sometimes it's really hard to name theorems, in my opinion. I don't know. Maybe that's just me, but like if you have like really complicated stuff, I think it's a little bit difficult to like name these things because I don't know. You're limited to like whatever symbols you're allowed to use in like a function name. Anyway, let's prove 0 plus n equals n. Delete sorry and replace it with induction n with dhd. Okay. Let's do that. Wait, where did that go? Where did the oh, here it is. So here's our little editor. Alright, so we started with 0 plus n equals n, and after this whole thing is run, we get 0 plus 0 equals 0. Interesting. So let's learn a little bit about how this works. I've kind of lost my place here. Yeah, don't forget the comma. Hit enter, wait for Lean to finish thinking. When Lean has finished thinking, we see that we now have 2 goals. Oh, actually, yeah, you're right. Oh, God. I didn't even notice that there was a second one here. I thought that was just like some other stuff that it printed out as like logging stuff. But no, there's 2 goals. So this is the base case, and this is our induction step. So the induction tactic has generated for us a base case, yep, with n equals 0, the goal at the top, and an inductive step, yep, the goal underneath. The golden rule, tactics operate on the first goal, the goal at the top. Oh, okay, good to know. Yeah. That seems different from cock, where it just like shows you one goal at a time. Or, well, I don't know, I guess it depends on like how it renders the goals, right? I guess for Lean, I guess in general they always render their goals in this order, but yeah, that's interesting to think about. The goals, so let's just worry about that top goal now. The base case, turnstile 0 plus 0 equals 0, so we can use add 0, which is the proof that x plus 0 equals x. So when we apply that to this, what that's going to do is replace the right side with the left side with the right side, and that just means that this 0 will be the one that gets used, and everything after this is deleted. So we'll get 0 equals 0, and then we can raffle that. So we can try rewrite, add 0. Yep. we can raffle that. And now we're good, and now it's going to make us solve the other goal. What do you think the goal changed to? I already kind of figured that out. Keep focusing on the top goal, ignore the other one for now. It's not changing, we're not working on it. You should be able to solve the top goal yourself now with raffle. When you solve the base case goal, we are now be back down to one goal. We are now be back down to one goal. The inductive step. Take a look at the text below the lemma to see an explanation of this goal. I'm all out of tea. That kind of sucks. For all natural numbers n, we have 0 plus n equals n. The text below the lemma to see an explanation of this goal. Okay, well, I guess they mean this. We're in the successor case, and you're... Why did they organize it like this? I guess because they wanted you to be able to see this at the same time as you're reading the stuff above? I don't know. It's kind of weird. We're in the successor case, and your top right box should look something like this. It sure does. Important. Make sure that you only have one goal at this point. You should have proved 0 plus 0 equals 0 by now. Tactics only operate on the top goal. Yes, we know. The first line just reminds us we're doing the inductive step. We have a fixed natural number d, and the inductive hypothesis hd. Saying that we have a proof of 0 plus d equals d. Okay. Our goal is to prove 0 plus successor of d equals successor of d. In words, we're showing that if the lemma is true for d, then it's also true for the number after d. That's the inductive step. Once we've proved this inductive step, we will have proved zero add by the principle of mathematical induction. Ooh. To prove our goal, we need to use add suck. We know that add suck 0d is the result that 0 plus suck d equals suck 0 plus d. So the first thing we need to do is to replace the left-hand side 0 plus suck d of our goal with the right-hand side. We do this with the rewrite command. You can rewrite add suck, or even rewrite add suck 0d. Alright, I guess we can do that. Oh right, the thing is up there now. So let's go rewrite add suck. Alright, you cool with that? Okay, so we went from 0 plus suck d to suck 0 plus d, because we just moved the suck out of there, and then, you know, so like a, you know, distributive law. So at this point, we're going to have to use hd. So we're going to rewrite with hd to get suck d equals suck d, and then we'll raffle. Let me just do that right now. Rewrite hd and raffle. And now we win. And we press enter, and then it'll say you beat level 1. Yeah, it seems like that new line is actually important for registering that you've actually beat the level. But yeah, these are all pretty easy. All right. Yeah, I did that. Or even rewrite add suck 0d if you want to give Lean all the inputs instead of making it figure them out itself. Okay, that's interesting. Yeah, because add suck is a function, I remember, right? It takes an argument. It's in our tactics box here, I think. Or no, it's here. Add suck there. Yeah, this is actually pretty useful. Being able to just look at the existing things. Like this takes 2 arguments, right? So they give add suck 0 and d. But it looks like it actually can take these arguments implicitly. So I wonder how you specify implicits in Lean, or if every argument can be implicit. I don't know. That's weird. Because I know in Idris, when you want to make an argument implicit, you supply it with like curly braces. But Yeah, it seems like you don't do that here. Unless this is hiding that definition from us. I don't know. That's a little bit weird. Maybe we'll see how that works in Function World, but that seems a little bit different from Idris at least. So okay. Don't forget the comma. Yep. And it did change to that. Remember our inductive hypothesis, HD, we need to rewrite this too. So I did that, and then we did REFL, and then we were done, so now we can venture off on our own. Those three tactics. Induction N with D, HD, will get you quite a long way through this game. Yeah. Using only these tactics, you can beat Addition World Level 4, the boss level of Addition World. All of Multiplication World, including the boss level, A times B equals B times A. Spoilers, gosh. And even all of Power World, including the fiendish final boss. Whoa. They don't tell us who the final boss is, but they'll sneak in. This is foreshadowing, right? You know, like sometimes in a game, like the boss from the next world just kind of like shows up, and I don't know, says something kind of goofy or evil, and then they leave. And you're kind of left wondering, like, who's that character? Will I see them again? And then they come back and they're like the boss of the next world. Like, I feel like that's what they're kind of doing here. You know, same energy. But Power World, we don't know. We don't know who the final boss of Power World is. This route will give you a good grounding in these three basic tactics. After that, if you're still interested, there are other worlds to master where you can learn more tactics. Yeah, from my understanding, these are kind of like the three big tactics that you usually tend to use. There's obviously other kinds of tactics that we're probably going to need later on once we have to like deal with tuples and like sum types, that sort of thing. But yeah, this makes sense. Like once we get into like and or, that's when things get a little bit more interesting. There are other worlds to master where you can learn more tactics. Yep. But we're getting ahead of ourselves. You still have to beat the rest of Addition World. We're going to stop explaining stuff carefully now. If you get stuck or want to know more about Lean, how to do much harder maths than Lean, ask in new members in the Lean chat. Login required, real name preferred. Kevin or Mohammed or one of the other people there might be able to help. Okay, I wonder if this is actually up to date. They're going to be looking for a guy named Kevin or Mohammed. Is this a Slack? What is this? I can't actually tell. Like that, it's kind of bleeding off the bottom of my page. Let me just like shrink this a little and see if I can view that. It's a Zulip chat. Are you serious? Okay. So I guess that's where the Lean community is, because I checked their subreddit and they have like nothing. It's like basically empty. I know the Idris community is on Discord now. I know they also have like a Zulip and a Slack, but like all roads kind of lead you to the Discord where like all the action is happening. So okay, that's interesting. It sounds, at least based off of this, that the Lean community is over on Zulip. So that's good to know. Good luck. Click on next level to solve some levels on your own. And I should say, I actually don't have a Zulip account. I've never actually, like, so the thing is, there's so many different like chat apps that I never really want to make more accounts for more like chat applications. I know there's like matrix bridges now, but like you still have to like allow the bridge and stuff like that. Like they have to allow it in, and I don't know. It doesn't feel like the matrix bridges really took off, because they didn't really solve the problem that they're intending to, because it's not as seamless as you would hope or want. But anyway, let's just move on. Alright, we've got associativity. Yep, don't forget to use the drop down boxes on the left. Yep. I don't think they're going to remind me to use commas anymore, are they? So now the gloves come off, so to speak. It's well known that 1 plus 2 equal, or no, 1 plus 2 plus 3 equals 1 plus 2 plus 3. If we have three numbers to add up, it doesn't matter which of the additions we do first. This fact is called associativity of addition by mathematicians, and it is not obvious. Wait, didn't I say associativity? Or oh crap, I'm dumb. I meant commutativity. I'm pretty sure. Commutativity is when you can like swap the order of things. Oh, so commutativity is the boss. Got it. Associativity is the sub-boss? 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 What? I've never heard of the term sub-boss being used in a game. Usually they're called mini-bosses, but okay. Alright. Sorry, I just need to clear my throat. I don't have any more tea anymore. I'm gonna be stopping in like 15 minutes anyway, so it's fine, but yeah. This fact is called associativity by addition by mathematicians, and it is not obvious. For example, subtraction really is not associative. 6 minus 2 minus 1 is really not equal to 6 minus 2 minus 1. We are going to have to prove that addition, as defined the way we've defined it, is associative. Okay. See if you can prove associativity of addition. Hint. Because addition was defined by recursion on the rightmost variable, use induction on the rightmost variable. Yeah, try other variables at your peril. I'm well aware of this problem, and this actually came up in a really good discussion about package management in proof languages, or like proof assistants versus regular programming languages, and what it means for something to be a breaking change. I'm going to go on a tangent here, so forgive me for kind of straying from the text for a moment. But yeah, the discussion was about like having a central math library, and this was in like the Kindlang Telegram room. So it was for a different programming language entirely, but someone was suggesting that they just try and do what Lean does, which is have like a central math lib library, and it sounds like that's what they actually want to do. But some people were asking like, why do we have to do that? And the main reason for that is because if you're using these kind of like mathematical theorems, right, there's only one universal definition for a lot of these things, but the way that you implement a lot of these proofs can affect how your proofs will work when you try to use that that proof. So like, for example, like here they're talking about doing induction on the rightmost variable instead of another variable, and yeah, sometimes you can get like much messier code, or you can get like completely stuck if you try to use or just like change the ordering of things, or you accidentally picked induction on one variable when the definition of the, or like the proof on the inductive proof for that variable actually requires you to use the other variable. Like if they did induction on the left variable instead of the right one, and you pick the right one, then it's just like, uh-oh. That's what they're kind of trying to point out here, but it means that when you just change the implementation, right, that's a breaking change for that proof. So like when it comes to things like semantic versioning for package managers, it's a lot less lenient when it comes to like theorems, right? Like if you try to do an optimization where you change the implementation of something, but the like external behavior of the function is the same, it's just that it's a lot faster, that's not a breaking change generally, and that doesn't really require like a major like version bump when you're using semantic versioning. But if you were to do the same thing, or like a similar thing for a theorem, that would be a massive breaking change, and it would actually like break every theorem that tries to use that, like the proof of that theorem. So like you have to be really careful when you're changing implementations, or I guess proofs. So anyway, yeah, that's a little tidbit about you know, proof assistance and package management, and why the situation there is so different from what we're used to in regular programming languages. Um, so note that when Lean writes a plus b plus c, it means a plus b plus c. So it's left associative. Got it? If it wants to talk about a plus b plus c, it will put the brackets in explicitly. Reminder, you are done when you see proof complete. Yeah, I know. Alright, let's give this thing a try. So here's our goal. A plus b plus c equals a plus b plus c. And yes, it did say that this is left associative by default. So that's why there's no parentheses on the left side. And we're going to have to use induction. So that's fun. They wanted us to use induction on the rightmost variable. All right. Okay. Let's quickly read this again. Okay, so we have to do induction on... So they do induction on n. Alright, and because it's defined like this, c is the rightmost variable, so we probably want to do induction on c with, I don't know, d. Alright, now we get two goals. Got it. So we're going to have to solve this one first, this top goal. A plus b plus 0 equals a plus b plus 0. So those parentheses around here. I think we can use a rewrite here, probably. Especially because we have add 0. That might get us a bit closer. Although there are parentheses here, so yeah, we don't really have a way of you know, saying that like this is associative yet. Oh, but then we can rewrite with this. Oh, okay, yes, we can use sorry, so to explain my thought process here, we can use add 0 twice, right? I'm going to do the obvious one, and we're going to use add 0, and we're going to rewrite the b plus 0, that was on the right-hand side, to just become a b. So we're going to go add 0b, and that should... What do you mean unknown identifier b? Are you serious? Okay, hang on, hold up. Rewrite add 0b. It didn't do anything. What? Oh, wait, because I didn't put the comma in. Right. There we go. Okay, I think I forgot the rewrite the first time, but there we go. Now that works. And now I want to be able to do the same rewrite, but with a plus b. I don't know if I can do that, though. What if I just do this? What would happen? Interesting. So what if I did this? Does it know how to rewrite that? I don't think it... Oh, it does. Okay. That's interesting. So yes, I can actually give it an entire expression. And it knows how to... It knows how to rewrite that. Okay. Good to know. Good to know. Alright, alright. And then we do rewrite add 0 with B. And now we raffle. That should clear goal number 1. Cool. Alright, second goal. We have A plus B, right? That's in parentheses, plus suck D equals A plus B plus suck D. Okay. And we also have this inductive hypothesis. We have to remember that. A plus B plus D equals A plus B plus D. That should actually be pretty doable if we use the add suck proof here. Right, add suck. And I'm going to specify... Okay, just trying to get the ordering here. So we've got a successor on the right-hand side of this, like, A plus B thing, right? I want to get rid of that. But if I do that... Okay, let's just give that a try. So what are my arguments then? So D is the second argument, because that's the one that's wrapped in the suck. So A plus B would be the first one. And then we have D here. Alright, so now we have that. I wonder if we can do it again on the right hand side. With B and D. Yes. Okay. And then we can do it again. Alright, that's good. And now we can rewrite with our other proof, with our inductive hypothesis. Very good. And now we can raffle, and then we win. Yay, we did it. And that's the end of level 2. Awesome. Cool. So that's that level done. I don't think we're going to have enough time to do one more. We can take a look at it, I guess. Oh, no. So in my head, I actually read that in, like, the Knuckles voice. Like the, oh, no. Suck, add. Okay. On the way to add column, a wild suck ad appears. Nice. Well, they threw in a Pokemon reference at the very least. So they are indeed trying to reference modern, or I guess semi-modern video games. I don't know, is Pokemon modern anymore, or even semi-modern? I guess stuff from like that era, like the Game Boy Color era, or not even Game Boy Color, but there's like old Game Boy games, not really Not really. Yeah, not really modern. I guess those would be considered pretty old now. Hmm. Yeah, I don't think I'm gonna do this one today. But this was fun. This was interesting. Probably gonna continue this on another stream, maybe next weekend. I don't know. We'll see. But yeah, let's see our overall progress. So we've finished all tutorial world and edition world. We completed like 2 of the levels there. Let's see if we go back in here. Yeah, it brings us straight back into level 3. So that's cool. Nice. All right, that's it for today's stream. If you decide to check this out in post, then yeah, thanks for watching. And yeah, I think I might stream more of this natural number game stuff. It's actually kind of fun, even if it is uh, fairly easy so far. Because I've done a lot of these kinds of proofs already in other proof assistants. It's kind of interesting to see like how it's done in Lean using their tactics and like their syntax and like yeah, just kind of learning the nuances of Lean's theorem proving capabilities. But yeah, that's it. Goodbye.